Welcome to the session on sharing and deploying MATLAB programs. My name is Benita Vormawar. I'm a Senior Application Engineer at MathWorks. In this presentation, we'll cover some of the different ways you can share your MATLAB applications, ranging from sharing a desktop application created in MATLAB to sharing with a wide audience via the web. I'll start by giving you a glimpse of what you can accomplish, ranging from sharing your applications that are written entirely in MATLAB within the MATLAB Apps Gallery, where you decide what custom functionality you want to expose to your end users. The same application could be shared as a standalone executable. Or based on the same algorithms, we could integrate our MATLAB algorithms into another programming language, for example, Java. So the user interface here is created in Java, but the functionality behind the application is MATLAB. We have the flexibility to integrate our same algorithms into a web application, which can reach a wider audience. You have the flexibility of creating simple user interfaces or even more complex ones. After you develop your algorithms in MATLAB, you can use them in a variety of different ways, without your users necessarily knowing that they are working with your MATLAB algorithms. The approach you choose will depend upon whom you're trying to reach with your work. We will start the presentation by showcasing a few techniques to effectively share your work in MATLAB with other MATLAB users, before proceeding to highlighting ways in which you can package applications for sharing with people who may not have MATLAB. To support both of these groups, the approach is to write your MATLAB programs once, maintain a single MATLAB code base. After you've created a quality MATLAB algorithm or application, you can share and deploy it in numerous ways. For sharing with other MATLAB users, you might share the actual files or create apps and custom toolboxes. We'll discuss those a little bit later. To share with people who do not have MATLAB, these may be internal colleagues or external customers. There's a range of options enabled by the MATLAB compiler suite of products, which we will highlight for you throughout this presentation. Now, this may seem like a lot of options to remember, but by the end of the presentation, we hope to give you enough information so that you can make informed selections as to which of these approaches may best work for your particular situation. The advantage of using MATLAB is that you don't need to recode your programs from scratch, even if you want to use algorithms within a different programming environment like C++ or Java. Let's look at how you can share with other people who have MATLAB and any of the relevant toolboxes being used in your programs. Once you have your programs in MATLAB ready to share, you have three options. Package an app that bundles together all your files for sharing easily as a single package. This is very useful in sharing programs in which you've created MATLAB-based UIs. You could also package an entire custom toolbox that you've written. You can include all types of MATLAB files in this: examples, code, documentation, and even apps. And the process is highly automated, so these files are automatically identifiable. Or you can directly share your code files and scripts with other users, including MATLAB Live scripts. We'll take a closer look at these options using one example. Because we're not all working in the same industries or with the same applications, we're going to use one standard example pretty much for our entire process here, just to reinforce the fact that you can take a single code base and create a number of different applications using that same code base. As we walk through this solar radiation estimation example, I want you to think about your own data, your own work processes, and the type of analysis that you are performing. But let's look at this in MATLAB a little bit so we can get a better understanding of the problem that we're actually working on. Okay, so here we have our information about our problem. A little summary and some visualization. We're actually going through the process where we work with MATLAB. We loaded our data from an Excel file. We did some visualization of it to find out that there was some periodicity associated with it, some sort of annual nature associated with our data. We parsed out data associated with that to get our year information, and then based on that did some visualization, because it's not only an annual circumstance that we're seeing, but it looks as if there's also some day of year impact, because what we have here is historical data from California where there are readings of temperature and humidity that were captured over time. And so there's a seasonal effect that we see here. We were able to subset our data set so that we could save some for our modeling process. And then we created an actual model based upon a known equation. You may or may not have a known equation to solve your particular problem, but the sense of being able to bring some data in, do some exploration, do some discovery, and creating algorithms that can then be used to make predictions is what we have here in this example. Based upon our model, we can add some new values and compare and see how well our results are. So this is something we could share with other MATLAB users just as a file. Our live script is one option for sharing with other users. And it's a nice way in which you can create a narrative and quickly explain what it is that you're trying to accomplish with the work that you're doing in MATLAB. Now that we have a general understanding of the problem we're trying to solve and the solution in which we want to share, let's look at some of our packaging options. So I could share this MATLAB live script with another MATLAB user. But what if I wanted to give them a more interactive environment to work with my solution? I could create a MATLAB app. MATLAB apps help you solve common technical computing tasks interactively. Apps typically consist of a user interface, underlying code for performing the intended actions, associated data, and other supporting files. Once we're sure the app runs successfully in our own environment, we can package it to share with other MATLAB users. Identify the main entry file. MATLAB does a dependency check to see what other files are required. And you can also add any additional resource files or data files that go along with your application. Put in as little or as much metadata as you like, and then it's a matter of package. When you package an app, MATLAB creates a single app installation file that enables you and others to install the app and access it from the apps gallery without concerns of installation details or the MATLAB path. Just like with apps, you can package your own custom MATLAB toolboxes. You can create a single file that contains all the code, data, apps, documentation, and examples necessary to use your toolbox. You can share this installer with other MATLAB users who can use it as an add-on to their MATLAB environment. Now that we have a MATLAB app to share with other MATLAB users, if we want to extend that with examples, documentation, we can package that as a custom toolbox. It's a similar workflow to the others that we've seen so far. You identify the folder in which you want to have your content for your toolbox. Some analysis is done by MATLAB to determine what tools and other resources are available to include with your toolbox. And then gives you a structured assessment of what is going to be included in your toolbox. So for this particular one, we have some examples, we have some overview or summary files, as well as the app that we created. With the package, and we're off and running. And what you get when that completes this packaging is a single file. We have one here that we can open already. When packaging is complete, it lets you know. But you would give the single installer file to another MATLAB user, and they can go through an installation process with your file. So once the toolbox is installed, it can be managed as any other toolbox in your system. When you install a custom toolbox, your help is integrated into the documentation. So you can easily access the information right within a familiar environment, so your users can navigate through your information as easily as they would MATLAB examples. What we just showed you were some different ways to share MATLAB programs with other MATLAB users. Now we'll show you some ways to share with people who do not have MATLAB. And we're going to use the same code base that we originally used for sharing with other MATLAB users. As we saw before, we have a lot of flexibility in the approaches we can implement to share our work with people who do not have MATLAB. At a high level, what we want to consider is, do we want to build our application entirely in MATLAB, or do we have a need to integrate our MATLAB programs into some other software? The MATLAB compiler enables you to generate standalone applications, Microsoft Excel add-ins, and Hadoop libraries. With this option, all programming is done within MATLAB. However, if you want to create an application in some other language and integrate your MATLAB algorithms into it, then the MATLAB compiler SDK generates components from your MATLAB program that can be called from programs written in C++, Java, .NET, or Python. Your intellectual property, or IP, is protected via encryption. The components and applications you create using this software can be shared and redistributed royalty-free. You only pay for the price of MATLAB compiler and the MATLAB compiler SDK. Let's look at each of these approaches. So without having to make any changes to our MATLAB code, we can use the application compiler app to package up the same application to be able to share with those who do not have MATLAB. MATLAB went through the same dependency check to see what other files are required to run the application. And then we're able to get a project file that we can use later on in case we need to go back and make updates. And it goes through the process of packaging up our algorithms so that they are strongly encrypted and made available to run as a standalone executable. But this takes a moment, so why don't we go back to our presentation for a moment and sort of talk through what the process is for sharing your applications that are built completely in MATLAB. You would have MATLAB and the required toolboxes to make your application work. Once you're sure it's working appropriately, you use MATLAB compiler to package your application and create an executable. The compilation process does not translate your MATLAB code, but provides a wrapper allowing you to run your code as an executable. The final step is to deploy that executable along with the MATLAB runtime to your target machine. The MATLAB runtime lets your end users run your MATLAB application without the need of a MATLAB license. The MATLAB runtime is downloaded from MathWorks' website, or it can be packaged with the executable for distribution to your end users. And so now we have available a single distributable file that can be used by our end users to install on their own system. By a single click, they can start the installation process, and then they'll be up and running with your application on their desktop. So our packaging is complete. If instead we wanted to package up some of our algorithms to use in another application, we can use a common group of functions and then choose which of the different targets we would like to build our example for. We previously looked at a Java integration, so let's look at that more closely. We can use our library compiler. We have a similar process in which we've identified the functions that we want to have exported. We can see the methods that are going to be used for this particular application, and we included some additional files with this. We package it. It goes through a similar process as it did with a standalone executable, but instead of getting just a single executable, now we're going to get components depending on the type that we've selected that then can be integrated into other applications. Here we selected a Java package, but it could just as easily have been a .NET assembly or a Python package or a C shared library. That's going to take a moment, so while that's doing that, let's walk through the process used to integrate your applications with other software. You use a similar approach for packaging up your MATLAB code to be able to have it integrated into another application. So you have MATLAB and the associated toolboxes on your desktop that run your application. You use the MATLAB compiler SDK to identify the target component that you want to generate. Say, for example, we wanted to create a .NET assembly. We could package that with the MATLAB compiler SDK and provide that to our software developer, who then incorporates that into their application. Their final application, along with the component, would then be deployed onto the system that has the MATLAB runtime on it, and then it's available for use from the various clients who are accessing that application. So I described this as if there were two separate, people who are working through this process of creating the MATLAB components and creating a different application in another programming language. But depending on the size of your organization, this may be the same person. When the packaging completes, we have an installer we could share with our software developer, and we see that we've created jar files from that build process. So this is just a high-level example of how you can build components and have them available for integration into larger applications. Using either of these approaches can save you time in avoiding the need to recode in another language. You reuse the work you've already done in MATLAB. Plus, this facilitates communication between MATLAB users and some of the software developers you might be working with. As a MATLAB user, you maintain the IP of the algorithm, whereas the software developer gets a finished package file to include within their own programs, using their own IDE such as Visual Studio or Eclipse. If you need to reach a large number of concurrent users, you can use the MATLAB Compiler SDK to package up your deployable archives that contain the algorithms that you want to expose to a larger application. That could be a web application in which you're serving up to a number of different web clients. You could be accessing databases, right? Reading and writing from databases via the web service or the components themselves. Or maybe you have desktop applications that can benefit from using these algorithms that you developed in MATLAB. You may even want to use an Excel as a front end for your desktop application and have your analytics be processed by MATLAB and used as an add-in in Excel. Or you may have some other application server that could leverage the work that you've done in MATLAB and incorporate it into your larger application. MATLAB Production Server is the out-of-the-box solution for being able to serve up these components in such a way that you could simultaneously support all of these different clients from a server environment. The MATLAB Production Server allows you to directly deploy MATLAB programs into production applications. The product manages multiple versions of the MATLAB runtime in support of multiple MATLAB deployed components built on different versions of MATLAB. It also provides for hot deployment of components. The architecture is scalable and reliable. You can serve large number of concurrent requests, and you can add capacity with additional servers as the need arises. MATLAB Production Server can be used with web, database, and application servers. Use the Production Server compiler app to build deployable archives for use with the MATLAB Production Server. In this environment, you have a dev and test capability so that you can do some debugging and prototyping with your MATLAB Compiler SDK prior to deploying to the MATLAB Production Server. But the packaging process is pretty much the same. You identify the files that have the algorithms that you are exporting, and they get packaged and ready for use. Then the final deployable archive is available for deployment on the MATLAB Production Server. MATLAB Production Server allows you to incorporate a packaged MATLAB program, primarily focused on numerical analytics, into enterprise applications. The product offers the following capabilities: server software. This manages packaged MATLAB programs and the pool of workers available to execute these programs. Runtime libraries. The packaged programs run against MATLAB runtime libraries, which include the same libraries provided in MATLAB, ensuring the same results as provided in MATLAB. A JSON RESTful interface. RESTful JSON interface allows almost any enterprise application to make requests to packaged MATLAB programs running on the MATLAB Production Server. Lightweight client libraries for C, C++, Python, .NET, and Java. So we covered a lot in this session, including the various different ways you can share the work you've done in MATLAB. And through our examples, I hope you've seen how you can write your MATLAB code once and then address different target audiences and environments through packaging your application in different ways to support desktop, web, and enterprise applications, as well as small groups and large applications that reach out to a number of concurrent users. The components that you generate using these approaches can be distributed royalty-free, and you have your intellectual property protected through encryption. Hopefully you got a lot out of this presentation, but if you'd like to get some more information, here are some additional resources if you want to delve in deeper and find more information about the various topics that we covered, so that you can identify which are the appropriate ways of sharing the work that you've done in MATLAB with other MATLAB users, as well as those who don't have MATLAB, and how you can leverage the work that you've done in MATLAB by developing once and deploying to various different targets.